Cool. Okay, so we're recording. Okay, today in class we're going to make an electric motor out of basic parts you can find around house. There are several types of electric motors, but this is the basis for all of them. Essentially, we have a power source, a battery, it works with a magnet, and it will run through a little induction field. So here's what you're going to need. You're going to need some wire. Specifically, we're using solid core wire. Solid core means this is a solid piece of copper running through it. This is nice because if I bend it, it will keep its shape. It is about 18 gauge. Gauge is how we measure it. You don't have to memorize all the different gauges. It tends to be the smaller the number, the thicker the wire. The larger the number, the thinner the wire. Just so you know what I'm talking about on solid gauge, you can have what is called braided wire. It's like this, and it's like lots and lots of little strands twisted together. This is really nice if you're going to be putting wire on something that moves a lot. It doesn't hold shape very well because it has all these little braids and strands on it, but it's very flexible. If I keep bending this, it's never going to break. A solid core wire, if I keep bending it, eventually it's going to break. So solid core is good to hold shape and be placed. Some of you may want to try, or later you can find wire like this that already has no insulation on it. It's called strip wire. If you buy this, it's normally called bell wire, because in the old days this was put on bells, like your house bell. It is pre-stripped. In real life, in most motors, this is the wire they use already stripped. Today we're going to use wire that has insulation on it. It really doesn't matter for this project. Then you are going to need a battery. We're using a D-cell battery. It is a DC power supply. It means direct current. It takes a little chemical reaction inside, and then it will provide batteries. I'm sure all of you have worked with batteries before. We're going to use a magnet. A magnet picks up metal. A magnet has a magnetic field around it, and it has a positive and negative end. If you've ever played with magnets, when you push the positive ends together, it will repel. If you push different ends, the positive, negative, they will stick together. You're going to need two paper clips. We're using paper clips because they're like wire itself. They will conduct electricity, and we're going to bend these out of shape. We're using paper clips because they're cheap. We're going to need a rubber band to help hold everything together, and a little wad of clay. The wad of clay just helps balance our battery and keeps it from moving around everywhere. To do this, we're going to use a couple tools. We have traditionally what are called needle nose pliers. They come in various sizes. They're great for jewelry. It has a little point. That's why it's called a needle nose. It comes to like a little needle. Some of you may use also wire cutters or dikes. Wire cutters simply cut wire. We can use it. Cut off a chunk of wire. Also notice some of the needle noses on the base will also have wire cutters on them, and we're going to use to manipulate. Okay, let's go ahead and begin. Do me a favor, zoom the camera in so you can see what's going on. Let me move our supplies to the side while you're doing that. So you're going to want to kind of cover this area right here. Okay? Let me know when you got it.
Right there, mister.
Excellent. Okay. First thing I'm going to do is take a little wad of clay and my battery. Batteries roll. It's kind of amusing, but it's really hard to work with. So just put a little chunk of wad of clay, stick your battery on it, push your battery down, ta-da, it doesn't roll. Makes it easier to work with. We're going to take our magnet. I also put a little wad of clay. You do not have to. The magnet will also stick on top. I like a little wad of clay. It just kind of keeps it from rolling everywhere, and it also helps keep it on top. So I have a battery on top. You're going to take your needle nose, hopefully don't get them stuck on there, and your wire, your paper clip. You're going to unbend your paper clip like 2 times. So you have a little hook like this. You're going to do this for both of them. Now what I'm going to do is I'm going to hold one on the side and I'm going to go up about 1 inch. And I'm going to grasp it and I'm just going to grab the end part, not the hook part, and wrap it around the end of my needle nose like that. So I have a part with a little hole in it. I'm going to take my second one and line it up so I'm going to get that bend in exactly the same spot. Line them up, grab it here, and spin this around so I have a little hole. It's not great art. Then I'm going to take them, I'm going to take my rubber band, I'm going to stick my rubber band over the battery like this, the long way. And I'm going to take one of my clips and stick it in on what is called the negative end, that's the flat end. And you want to make sure the metal of the paper clip is touching the metal of the battery. On one end you have like a little nipple. You want to make sure you're touching that and sticking up. Then I'm going to stick it on the other end, pull the rubber band out a little. Don't let it stick to the magnet. And voila. Now, next part, I'm going to take my solid core wire. And I'm going to take a little part of the end and strip it off. You can use wire cutters. If you're real careful, you can use the little cutter end just to cut the insulation and pull it off. But you're going to want about 1 inch of bare wire. Going in from the bare wire, I want to loop this. And I want to make a loop about the size of a quarter. It doesn't have to be a monstrously big loop. And I'm going to wrap it like 3 times. 2 or 3 times. You can keep wrapping it. The number of wraps will change its rating. And I'm going to wrap it like 3 times. What we're doing is we're creating an inductor. The end with the bare wire, I'm going to wrap it inside the loop a couple times. I'll have a close-up picture. So that's there on the loop on the end. Directly across from it, imagine this was the line I wanted to bisect the circle. It should go straight across. Directly across from it, I'm going to take my wire and I'm going to wrap it through once or twice. So it will stick out again. And then I'm going to kind of measure it on my motor. This copper part should stick through this loop. This should be in the center of the magnet. And then I want to cut off my excess I need here. If you use too much wire, you can just cut it off. Then I'm going to strip this little bit of wire. So I have a little loop about the size of a circle with a copper arm on each side. What is this loop is called an inductor. And when I run electricity through it, it's going to have an electrical field which also has a positive and negative end, which will react with the magnetic field. Now if these are directly across, I should be able to grab each end and spin it easy. If it doesn't spin easy, if it's lopsided, you just need to play around with this a little bit till you get it. Now, once I have the wire, I'm going to run this in through those little holes I made. And what's happening now is current is going through here and it's making a little electric field there with positive and negative ends which react to the magnetic ends. With a little boost, if I did it right, it will start spinning. And if I can get it closer to the magnet, it will probably spin a little better. So I want to tweak it. You don't want to touch the magnet, but you want to get as close to the magnet as you can. With a little bop to get it going. You notice the magnetic field, the positive and negatives, react with the coil field and start spinning it. If it's a little unbalanced, I may need a little twisting. You notice it's a little unbalanced. I could probably take this part and try to get it where it's a little more centered on my circle. Same with this end, maybe get just a little more centered. Oops, notice how I bent that. Yeah, you're gonna have to play with it a little bit. But eventually you'll get it and it'll start running. Gotta find that little sweet spot. Oh, so close. Now you have an electric motor. In real life, if I attach something to one of the ends, it could cause it to spin around. So what I've done is, so your mission today is to build an electric motor like the one I have here. If you're doing this at home, you're going to need to send me a picture or a video of you doing it. In class, you can just call me over and I can go, cool, you got your motor running. Okay, stop the video.